Hello, guys. We're at the very end of the road. We're going to do a little bit of conic sections, and we'll see how far I can get. I'm going to do this first lesson standalone, and then I'll do two more lessons together. Basically, a conic section. Well, we're going to do parabolas today, and you've done parabolas before. You did parabolas in terms of algebraic equations, and also with the graphs. And a lot of it's the same, but we're going to look at it through the eyes of where they came from. And down here, I have a picture of a cone. Well, there's three cones. A cone is, you're used to just one part, like an ice cream cone. But in reality, the geometric cone, it's joined at the vertex, and there's another one. So let's picture that solid that we're looking at. And you need to realize that the cone goes on forever. So it just keeps moving up. So if you take a cone and you slice it like a diagonal slice, see this slice in here? Then the imprint you get of the cone, of where it actually touched pieces of the cone, in this, if you do it diagonal, you get pieces of, you get a picture of an ellipse. It's the side wall going to the other side wall. And if you put a piece of paper in there, you could trace out the ellipse. If you and if you cut out horizontally, not diagonal, we've done these already. These are circles, and you could have a circle down here too. Matter of fact, the base is a circle. If there was a base, and remember I said it goes forever. Now, if you slice it, it's another diagonal cut. But how this one went from one wall to the other wall, what if you go from a wall to the bottom? Wall, bottom. But remember, the bottom keeps going forever because this keeps going. So anyway, you could picture it extending out. What's that look like to you? Parabola. So ellipses is new for you. Circles we did in chapter 2. Parabola you did in algebra. What if I make a cut vertically on this cone where it ends up cutting the top part and the bottom part? And you might be thinking, oh wait, that's a parabola, but it's not a parabola. Because there's another piece down here. They go together. And what you don't see, this cone does go up forever. So what this piece would do, it's going up forever. It's in here. And so it actually gets straight. Unlike the parabola, always will have some curvature to it. As this cone gets extended, you'll always have some curvature to it. This is called hyperbola. Hyperbola. You can think of hyperbola as what happens when space debris is coming towards the Earth. Coming towards the Earth, and the gravitational pull slingshots it around the Earth, and it goes back out to space. That's the path of hyperbola. All right. Now, this lesson is on the parabola geometrically as a conic section. So the formula we're going to start out with looks very familiar to what you've seen before. You may have seen a formula like, well, I don't know why he's doing this to us. He's switching the axis horizontally. He's talking about a parabola that looks like that. An axis, a horizontal line of symmetry. So notice inside this parenthesis, the y is being squared. Now, you might have been more comfortable with y minus k equals a x minus h squared, because you've sort of done this before. If I was to rewrite that as to y equals a x minus h squared plus k, we had learned that the vertex is opposite of what's inside the parentheses, so it was minus h k. To the right h up k was my vertex. Okay, so it's the same idea as this equation, except we you have never exposed yourself to a parabola that opens left and right. So now the h still follows the x and the k still follows the y, but this time the y minus h is being squared. So my vertex now, well, it's still hk, but this is going to give you, since the y is being squared, it's going to give you this parabola that opens to the right. The y is being, as long as a is positive. Remember, it was about the number in front. Like here, it could be plus or minus. That means it opens up or down. It's the same thing here. I think we're going to talk about the parabola opens to the right if a is positive, and obviously left if the a is negative. So this is the equation you want to get familiar with today. X minus h equals to sum a times y minus k squared. Okay, so let's try our first problem. And we're going to start out with the horizontal axis. So you know what that means. It opens up left and right. Now, when you look at this equation and the y part's being squared, that's how I knew it's going to go up left or right. I also can tell that the a is a positive 1, so it's going to go to the right. When I rewrite this, you still need to realize that the left side can be written as x minus a negative 3. And that's important because it tells us that our x value is the opposite of 3, which is the negative 3. That's why I wrote it that way. Equals to the 1 times y. And we already know that I do the opposite. We know we're going to be going up because that is negative. So I'm just going to rewrite that. And so I know I'm going to be going to the right, and I'll be going up. I'm sorry, I lied. To the left. Left, it's meant left. And I'm still going to go up opposite of that. So pretty much I'm doing opposite of both pieces. You see positive, I'm going left. I see negative, and the thing in the y being squared, I'm going to be going up. So let me take my table, and I didn't graph the vertex. I did write left and up, so let me go vertex. Opposite of a 3 is a negative 3. Opposite of a negative 2 is a positive 2. So negative 3, 2 puts it up there. So here's my axis of symmetry. And it's horizontal. And so this is going to open up like this. Just got to find out some easy x's to plug in. Since I know my vertex is over there at negative 3, 2. So 3, 1, 2. I know that's my vertex. I can put that out. I can put that here. Negative 3, 2 is my vertex. Let's pick x is a negative 2. See what happens right here. So So if I put x is a negative 2, and I plug that in, if x is a negative 2, here goes, I'm going to plug it up there. It was a x plus 3, so I'll go negative 2 plus 3 equals to, in parentheses, the y minus 2 squared. Negative 2 plus 3 is a 1. Y minus 2 still squared. I'm not going to square it out. I'm gonna get rid of the square by squaring both sides. Square root both sides. Square root of 1 is a 1. Y minus 2, now I add 2 to 3 equals 2y. So I have a negative 2, 3. Well, let's see. Corrections. I square rooted both sides right here. That means plus or minus. So what happens is I do have the 1, but it was a plus or minus 1. So I do have y is 3. I also have y is, if it's a negative 1, negative 1 plus 2 is a 1. So I have that negative 2, 3. So I have the negative 2, 1. So let me put those there. Negative 2, 3. Hey, it's almost right there, perfect. And negative 2, 1, almost perfect. Let me do one more set. Let's see what happens on the other side of the x-axis. Let's do a 1. Let's see what happens over here, 1. So I suspect there'll be 2 answers again. So the equation again was x plus 3, so that's going to give me 1 plus 3 equals to the 1, and the y minus 2, I don't know why, so y minus 2 squared. That gives me a 4 equals to a y minus 2 squared. Take the square root, and again, what happens is I get plus or minus 2. I took the square root of both sides, I get a plus or minus equals to a y minus 2. So when I have a 1, I would have a 2 plus 2, that's a 4. Or I have a 1, if that's a minus 2 plus 2, I believe that's a 0. Double check the math, please. Because it's easy to make a mistake. I believe it's okay. 1, 4, and 1, 0. 1, 4. 1, 0. Well, yeah, it does look like it's fitting the picture. And I'm just going to continue it. Okay. Is there another one on this page? There is. All right, still graphing a parabola. The reason why he jumped to parabola horizontals is you've been doing horizontal or vertical parabolas forever. This time, it's written in a different form. It's actually solved for x, which is not strange. You've done this before many, many times, solving for y, when it was a vertical. So that's not a big thing. So let's see. How would I solve it? I do the exact same thing I've done before. Can I factor this? It looks the same as before. So let's see, what could I do with 2y squared plus 6y plus 5? I'm gonna factor it and realize that 2 times 5 is 10. That's this and this. Factors of 10 that could add up to 6. Maybe, are there any? 5 and 2, 10 and 1. Nope. It's not going to do it. Hey, I got an idea. We could do quadratic formula. We could do completing the square. Let's complete the square for old time's sakes. or I'll do them both ways. We'll do quadratic formula. Y will be the opposite of b. Now this is b, minus 6 plus or minus the square root of b squared, 36, minus 4 times ac, that's 10. 36 minus b squared minus 4 times 10 minus 40 all over 2a, which would be 4. Well, that didn't help a whole lot because look at my discriminant. Here I got excited for no reason at all to use quadratic formula or completing the square. It's going to be the same thing. That's going to be, I don't know, I didn't write the b. It is minus 6 plus or minus square root of a negative 4 over 4. And you know that's a complex roots, negative 6 plus or minus 2i, each over 4. That means what happens is, wherever the vertex is, and I haven't found the vertex yet, I will use the old-fashioned method in a second, but it doesn't cross this axis. It opens up somewhere this way, so it doesn't have a 0. So what did I just do? I spent a lot of time for nothing. All right, I'm going to hide the evidence, since that didn't give me a root. That didn't help me find the vertex very easy either. Let's put this in vertex form, because I need to find the vertex. So I'm going to put the x minus 5, I keep writing the wrong thing, x minus 5, moving the 5 over, leaving the 2y squared plus 6y. Now, the reason I'm doing this, if you remember the first problem we did up here, it was an x plus or minus a number. I did the same thing. So what would I do to finish this up? X minus 5, factor out a common term. In this problem, the common term is a 2. So I have a feeling that that's going to be my a number. Now I'm left with a y squared plus 3y. 6y. No, 3y. I need to complete the square on this side in order to see what is going to be squared. I need x minus some number plus or minus an a, y minus a different number squared in order to find out what my vertex is. My vertex would be like the opposite of C, whatever's happening, or C, in this case, C, D. You know, so I need to have it in that form. This is not very pretty. Thank you, Pearson. How do I do it? I take this number, take half of it, 3/2. And then I take 3/2 and then I square it. Remember I had to square it? That gives me 9/4. So I have to add 9/4. It's kind of a dirty trick because it is a 9/4 going in here. But I also, if I add 9/4, I've got to subtract a 9/4, but remember the 9/4 is being times the 2, so it's minus 2 times 9/4. Because you add 9/4, take away 9/4, but since if I put it inside the parentheses, take away 9/4, and I want to pull it back out, it's 9/4 times 2. So that's what I did. I pulled it out of the parenthesis. And I need more room here. Let me get rid of this mess. So this turns into x minus 5 equals 2 times, why did I do this? To write y plus 3/2. That was half of 3, remember? Squared. And then I have this minus 18, well, that can reduce to 9/2. 18/4 is 9/2. But what I do with 9/2? That's 4.5. So if I add 4.5 to both sides, I get x minus 1/2 equals 2 times y plus 3/2 squared. Okay, I have everything I need here. I have my vertex. It's going to be the opposite. It's going to see the opposite of what you see, so it's 1/2, and it's going to be a negative 3/2 on the y. Is it negative or be positive? I wrote it wrong. Or I may have said something wrong before. Opposite of this on the outside, and I'm going to keep the... No, it is going to be written as 3/2. It is written correctly. I'm right. It is vertex will be, we got to zoom in on this, fractions. It's going to go to the right, because it was the opposite of what you see, so it's going to be right. And it's going to go opposite of what you see, it's going to go down. Right 1/2, down a negative 1.5. Yikes. Right 1/2 and down 1.5. It's going to go down about here. Who in the world has eyes that good? There's my vertex. Hold that thought. Let's make a little table. Again, let me get a couple ordered pairs. Let me see what happens when x is, let's move out to the 4. Let's see what happens when x is a 4. Remember the equation. That's going to be a little hard. Well, the equation, I'm going to rewrite it. Let's see. It was x equals to 2y squared plus 6y. If you were here, I'd have you read it to me. Plus 5. And if x, I'm going to use a 4. And that's why I told you before, like especially in this case, it'd be so much better to plug in a y value. So I think that's what I'm going to do, only because this is, well, this will be doable, but I'll have to factor and do all kinds of work. So let me do it. Let me take back my words. Let me plug in the y value. What y value do I want to look at? Well, let's see what happens when the y is a 2. Let's see what happens up here. Let's do a y is a 2. That's going to be so much easier. If y is a 2, then I can do this. X will be 2 squared is 4, it's 8. 2 times 6 is 12. X is 20. Yeah, there's a 5 up there, 25. Do I really want to do that one? I can use that one. What did I go? X was a 2, so X will be a 25. That's way off the graph. So I better think closer to the vertex. How about x is, or the y is 0? Because I went y is a 2, it was too far up. And if this is a skinny parabola, it won't go up there. So let me do y is a 0. Right here. I don't know what. So if y is a 0, that's going to be easier. That goes to 0, that goes to 0. You get a 5, x will be a 5. Okay, so 5, 0 will be doable. Here it goes. 5, 0 is doable. But let me give you a secret. This is a line of symmetry. So even though I'm 1.5 up from that line of symmetry, if I go 1.5 down, I have the other point. At 5, I also have a negative 3. At 5, I also have a negative 3 based on symmetry. So there's my picture. No wonder I wasn't going to get that 420. it was never going to get 25 in a long, long time. It's going to go up and it's going to go up, down. It's going to be a long time before it's going to get to the y value of 4. It's going to take it till I get to 25. I don't want to do that work. Okay, I didn't talk about the domain for either of these problems, but I hope you can see it, that the domain of that first one is all the numbers starting at that x value of the vertex, which was a -3. So it was a -3 to infinity. And the range was going to be all real numbers, -infinity to infinity, because it's going to go up forever, up and over forever. So it goes up forever, it goes down forever. All y values are included. And open, I included the -3, but you never include the infinity. For this one here, it's going to be where the vertex was the x value of the vertex. The domain, the vertex was at a half, I think it was, wasn't it? Yeah, I think it is. And obviously, it goes forever. And the range would be, again, all real numbers.
Okay, now that we've done pretty much the same thing with parabolas we've done before, except we're doing some horizontal parabolas, let's look at what the real reason we're using this lesson called conic sections. Conic sections is a geometric definition of circles, of parabolas, of the ellipses, of hyperbolas. So first of all, here's your typical parabola. He did us a favor. It's vertical. Notice definitions that are in this picture. I may or may not fit all the things in the definition at the top, but there is your familiar vertex right here, which that isn't a surprise. You know that's the bottom part or the top if it was up and down. But in geometry, we have two more pieces of a parabola. We have a point called a focus, and it's inside the parabola. It's always inside the parabola. If the parabola was upside down, the focus would be in here. And then this distance that we have straight across straight across, above the vertex, below the vertex, you have a horizontal line. It's called a directrix. These two distances are equal. So if you find your vertex and you figure out where your focus is, go the other way outside the parabola and draw a horizontal line. Or if it's I hate to tell you this, if it's a horizontal parabola, then your focus will be inside, and that distance here, you go on the outside, and you have a vertical line. That's your directrix. So let's see if a parabola is a set of points in a plane equidistant from a fixed point and a fixed line. That's my fixed point. This is my fixed line. Everywhere on this parabola, if I have connected straight a perpendicular to the parabola, no matter which way I'm going to go, there's another distance here is the same. It's not perpendicular. It can be. This is perpendicular. That's the same distance. That's not perpendicular, but that's the same distance as that. It's a fixed distance. Every point on the parabola is the same distance from the focus as from the directrix. That's the geometry. So what is he wanting me to fill in here? Set of points, equidistant, fixed point, and a fixed line. The fixed point is called the focus. And if you have two of them, we call foci, but parabola only has one. And the fixed line is called the directrix. So now if you go to the next picture, we've labeled that distance between the focus and the parabola called the distance called p. P is just a number. It's a distance. So once we identify p, we go to the vertex, and in this case, we go up p distance to find the focus. We go down p distance to find where we're going to draw our horizontal line. All right. The parabola with a focus at 0p, and the directrix is negative p. Well, because you went down. Obviously, this is going up p distance to get to the focus, down p distance to get to the line. And so whatever, if we were at the axis, obviously negative p would be the equation. So knowing that, this is your generic formula for the conic section of a parabola. Think of it, whatever is being squared is equal to 4p times the y. Now this obviously is 0, 0 is your vertex, because he told me that right here, okay? So I'm not doing, I could have had an x minus some number squared equals to 4p times y minus some number. That would be a fancier version of the same thing. But if you're at 0, 0, I don't have the a and the b left and right, up and down. So the parabola has a vertical axis of symmetry. And I don't know if he wants me to say what it is. It'd be x equals to 0. And opens up if basically the 4p is on the outside. And if it opens up if p is greater than 0. If you solve it, and you end up getting p is greater than 0. Down if p is less than 0. Let's see if it matches up the pictures here. 0, 0. 0 comma p means I go up p distance here to get to the focus. P has to be greater than 0. That means it opens up. So once I found this distance p and I put my focus, I'm going to go the opposite of p, put my point, and draw a horizontal line. And you have to remember, it's kind of like the parabola is a cup of coffee sitting on its plate. Unfortunately, this cup of coffee is upside down. How sad. That meant p was negative because the focus had to go down from the vertex. So we had, even if I say 0 p, I find out that p was negative. Okay, so and then I go up p, and I have the equation of the opposite of p, because if p was like a negative 2, I went down 2, and negative negative 2 would be y equals to 2 up here. Horizontal axis of symmetry. Now if I turn them around, what changes? Well, this time my focus is going to go left or right. So I'm solving for y squared equals 4px. If you look at the picture, what's changed? I still have to find a vertex. But this time my x value is the p. P over, comma 0, means I don't go up or down. And my directrix is the opposite distance p. The p is an x distance. And so this one opens right because p was greater than 0. And if p is less than 0, it opens up to the left, and my focus is still inside. So let's see, the parabola has a horizontal axis of symmetry. With a horizontal axis would be y equals to 0. And it opens to the right if p is greater than 0. It's an x value now, though. And left if p was less than 0. So this whole page was just some notes. Okay. Now let's use this idea of focus, directrix, and axis of symmetry. Take whatever form he gives it to you, you must solve it for what's ever being squared. That way I can look into here and realize that 4p is equal to 8. That number is 4p. So p is going to be a 2. That means it opens up or it opens to the right. And since I'm solving for x squared, we know it's going to go up because the x's are being squared. So this has a vertical line of symmetry. But I didn't find the vertex yet. Well, I hope you're not surprised if I tell you, using my sophisticated mental powers, the vertex is at 0, 0. Why do I say that? There's nothing being added to the x being squared. There is nothing if I write 4p times y minus 0. There's nothing, so my vertex is 0, 0. Normally I would look into here to see what the numbers were inside the parentheses, but so 0, 0 is my vertex. My focus has to be 2 to the right, or I'm sorry, 2 to the up, because we already said it opens up because the x is being squared. So my focus is up 2. My just a point. And I know my parabola is opening up like that, okay? So hold on here. And then so down 2, 1, 2, means I have a horizontal line. So I'm putting a couple of points just to give me some guidance to draw a line. Focus, directrix, vertex. Now let me find one point. And then if I find one to the right, I know I have the opposite side because of the symmetry. And the symmetry is at 0, so it's going to be very easy. Why don't I let x equal to 4? I like x as 4 all the time. Using my equation, x squared equals to 8y, and it was 4py, but I already found p, so I don't care about p anymore. So I know 16 equals 8y, because I went 4 squared, and then y must be 2. So x is 4, y is 2. Now, did you realize that, and I did mention to you that if I have a point over here, then I have the reflected over the other side. So let's see, it's 1, 2, 3, 4. 1, 2, 3, 4. I have that over here too. Are you expecting it to be fat? Sort of a big number out here. So it goes out like that. And let me prove to you that if this was with x equals to 4, what if x was equal to the negative 4? Well, negative 4 squared equals to 8y. Doesn't change anything. I still get y is equal to 2. So at negative 4, and I think I was too far over. Yeah, I think, let me fix my graph a little bit before somebody messages me and says, your graph was off. I'm going to say, surprise. So it was negative 4 up to, negative 4 up to, so it was not exactly perfect. But I'm never exactly perfect there. Okay. And it makes sense that these two ordered pairs are symmetrical to this vertical line of symmetry. Vertical line of symmetry. Okay, I did everything. Do one more. Same thing. Vertex is at 0, 0 because I don't see anything being added to y, anything being added to the x. So I need just to know that 4p must be a negative 28. Right here, I get it from here. So p must be a negative 7. So, and it's the y being squared, so it has to open up left and right. And since p is negative, it opens left. And it has a horizontal line of symmetry. So I'm going to go and I'm going to count. Well, here's my vertex. Count 7 left, right here. Call that my focus. 7 to the right And this will be my directrix. The directrix has to be vertical because the parabola is opening up like this. Now, at this point, we haven't learned any other tricks, but just plugging in a point. So if I say let x equal to a negative 2, let's see what happens. If x equals a negative 2, I'm talking about somewhere on this line. I want to see where that point is. And look at, there's going to be 2 of them, okay? You have plus or minus, so keep that in mind. So y squared will equal to a negative 28 times the negative 2. Y squared would be a positive 56. Well, unfortunately, that's not very pretty. Because when I take the square root of both sides, I have plus or minus square root of 56. I know it's between 7 and 8, because 7 times 7 is 49, and 8 times 8 is 64. But if you were to maybe factor it out like this, that plus or minus square root of 4 times square root of 114, square root of 14. Well, okay, that doesn't help me. That's plus or minus 2 times the square root of 14. Square root of 14 is less than 4. Slightly less than 4. So plus or minus 4 times 2 is 8, plus or minus 8. So I know I'm going to go, my y value is going to go up higher than I thought. Not quite to the 8. Not quite as low as a negative 8, but something like that. And was I expecting it to be a very fat with a negative 28 in front? Yeah, I think so. All right. All right, example 4. Write an equation for each parabola with the vertex at the origin. So we know, I'm looking at this ordered pair. If the vertex is here, let me change the color so you can see it. My vertex at the origin. And my focus is at 2/3 0. And here is a 1, so 2/3 is roughly about here. There's my focus. And this was my vertex. Then what do I know to be true? I know that this parabola is opening to the right. Why do I know that? Is because it has to eat the focus. The parabola opens up into the focus. Focus is inside the parabola. So it has a horizontal line of symmetry. So how can I solve this? I know the generic form would have been y squared equals 4py, since it's at the vertex. If I only knew what p was, interesting. Do I know what p is? It's the distance from the focus to the vertex, which was at 2/3. 2/3. So I know p is 2/3. And how did I know it opened to the right? I wasn't really, I guessed at that. But since I know that p is 2/3, well, I knew it to the right because it has to eat the focus. I'm right. I was right. So let me plug that p into here. So y squared would be 4 times 2/3 ay. That would be 8/3. Y squared is 8/3 y. There's your equation. Easy peasy. What about a vertical line of symmetry? That's what this means. And we know that this line of symmetry, and there's a point on that parabola, negative 212. So what does that look like? It's still 0, 0 because he told me up there at the beginning. He says they're always at the origin. So I'm at the origin, and it's a vertical line of symmetry, so it's that line. And the parabola goes through negative 2, 12. Negative 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Way up there. Way over there is a point on that parabola. So how can I go from here to there other than it has to be going up? And that must mean the focus point must be inside, as this thing's going up pretty steep. The focus point, because it has to go up and touch this, so symmetry. Focus has to be somewhere in here, somewhere in there. So we may have to find that. Well, let's write the equation. This time I know it's x squared equals to 4py. And it's so simplistic because it's at the origin. The focus is, the vertex is, remember? And so why don't I just plug in this ordered pair and see what to solve for p is what I really need. So negative 2 squared equals to 4p times the 12, which is 48p. That's 4 divided by 48 will equal to p, which is 1 out of 12. So the equation is, that's all I wanted was the equation, x squared equals to 4 times, I already reduced it. 4 times 1/12 y. That would become x squared equals to 1/3 y, or y over 3. Now he's going to talk about the translated parabola. You see what I have here? If the x is being squared, minus h. If the y is being squared, minus k. Because they basically flip-flopped 4p, y minus k, y minus h. Okay, because remember, to find my vertex, it was a little more challenging to find the focus and all that when it was translated. Do I need to fill anything in? Well, obviously this would be a vertical axis of symmetry y because the x is being squared, see? This would be a horizontal line of symmetry or axis of symmetry because the y is being squared. And we always know that the focus is the distance between the focus and the vertex. Just a straight distance is the absolute value. The plus or minus tells you whether it goes up or down, left or right. Okay, now he's doing the whole full meal deal on this one. We're going to write the equation, and then we're going to graph it, and then we're going to give the domain and range. So write the equation of the parabola with a vertex at 1, 3. What I might do is write out the general equation. Here's what I need to do. I need to know if it's vertical or horizontal. So let me just do a couple graph points. The vertex is at 1, 3. And the focus is at negative 1, 3. Focus and vertex. So what does that tell me? It tells me it opens to the left. That's the only way I'm going to be able to eat that focus point, okay? So it's going to have a horizontal line of symmetry. The equation I'm going to want to use would be where the y is being squared. So that's y minus my k squared equals to some number, 4p, that's my some number, x minus h. See, the h always follows the x. Okay, now what do I can do? Well, I already have the vertex. Hello? I already have the vertex. It's at 1, 3. So that would imply 1, 3. And they're both negative, so it stands for positive values, because you take the opposite, minus, minus, minus. No, that's not minus, that's just a minus. So this is my h and this is my k. There's no minus in front. So far I have y minus 3 squared equals to 4p x minus 1 squared. All I need to do is find out what p is to get the whole equation. Remember what p is. It's the distance between the vertex and the focus. So if this was at x is 1 and this is x is negative 1, that distance is, your distance between two numbers is always going to be the absolute value of the last number, or the one on the left, negative 1, minus the 1. That's the absolute value of a negative 2. That's a 2. So that distance is 2. But we will use negative 2 because it's opening to the left. So p is negative 2. So I have my equation. Y minus 3 squared equals to a negative 8 times x minus 1 squared. There's my equation. And I already really have it graphed on my left-hand side. I almost have a perfect graph. But let's go ahead and put it on the grid. Vertex was at 1, 3. Focus was at negative 1, 3, as I recall. Yes. We know it's opening to the left because p was negative. I just need to probably have at least one more solid point. So that's where we can take x. What would be the easiest to plug in? Well, what is this for? Let's plug in an easy x of 0. And so the equation I have was y minus, been lost, minus 3 squared equals to negative 8 x minus 1. Why do I keep squaring that other side? I did it twice. Nobody told me anything. There. That is squared because it was a y squared, meaning it's going to be a horizontal axis of symmetry. Okay, so solve this equation. If x is 0, then y minus 3 squared equals negative 8 times negative 1. That's y minus 3 squared equals to if that's a negative 1, it gives me 8. Take the square root both sides, plus or minus. Obviously, I'm going to need 2 of them because this thing opens that way and that way, so there's got to be 2 of them. And I don't like the square root of 8 because it's not very perfect. So y minus 3 is a plus 2 square roots of 2 or a minus 2 square roots of 2. Because square root of 8, remember, was square root of 4 times square root of 2, which is 2 square roots of 2. And it's a plus or minus. So 2 and a little bit more. Let me just do that. From the 0, 2 and a little bit more. How do I do that one? If x is 0, 2, okay, it's 2 times the square root of 2, which is 1.4. It's almost 1.5, so it's going to be plus or minus, should I have a decimal number for it? Plus or minus. It's going to be between 2 and 3. How's that? Is that good enough? From the axis of symmetry. So let me erase what my chicken scratch that gave me an idea of what the thing's going to look like, which was true. So let me go from the 1, let's see, 1, 2, I'm about here, 1, 2 down here. So here it's going to open up. Here it's going to open up. I could do more work if you want to get a perfect look. But roughly we know it opens up that way. Oh, Directrix would be, let's see, the distance between the focus was, what was that distance? 1, 2, and a little more. 1, 2, and a little more. So my Directrix is looking like about here. He didn't ask for the Directrix, but is that the last one on there? I didn't answer the domain and range, which should be old hat, guys. Domain will be the set, well, let me just go, is from, that x value was a negative, was a 1 right here. Starts here, and we got to go everything to the left. So I'm going to go from negative infinity open all the way till we get to the 1, and I can close that. The range, though, it goes forever and ever up and down, negative infinity to infinity. Okay, I feel like I finished it. Do I want to do an application? We'll start it, because at least you can see why we have these parabolas in terms of a conic section. This is a satellite dish speaking to the aliens out in space. There's your parabolic dish. This receptor right here is your focal point. Science and math has determined that if radio waves or X-rays are coming into being caught by this dish, that those that get caught by the receiver being at this focal point, well, it allows better capture in the dish here, because this focal point, that distance from the dish and the distance from the vertex are always the same distance. So you're concentrating a signal. You're concentrating all these various signals in, and it's always going to be reflected well into this dish. And this is a radio telescope, so it is catching radio waves. It's parabolic dish. Diameter is 210 feet with a depth of 32 feet. Isn't that? The depth means where they stop making the dish. That's how high it is. That's its depth. They could have made more depth. That's not going to hurt. But from the diameter being 210, it's a big dish. It says here, because of the parabolic shape, distant rays hitting the dish will reflect directly towards the focus. And a cross-section of the dish is shown in the figure. Okay, we just looked at that. Determine an equation that models the cross-section by placing the vertex at the origin. So when you do your graph, just pretend that you are putting 0, 0 here. And then we can come up with the other numbers, okay? So what do we know about the focus? The focus was Did he tell us how far the focus was? I don't think he told us. Let's just run with it as a math problem. X squared equals to 4py. And I can come up with a couple of points because I know that the diameter was 210. So from here to here must be 105. From here to here, it's the half the diameter. That would be at negative 105. If you think about the x value, how high am I going? Well, he said its depth of he said the depth was 32 feet. The depth is 32, so this ordered pair would be 105 comma 32. This ordered pair on that parabola would be negative 105 comma 32. So if I draw that out and just pretend that's a big dish, and I know that ordered pair at 105, and this was up at 32, negative 105 up at 32, we should be able to find P, because all I need is an ordered pair, and I got an ordered pair now. So if my x is 105, I'll go wrong color, wrong shading. Still wrong color, I wanted red. 105 squared equals to 4p, and the y is a 32. And 32 times 4 is 128, so 105 squared equals 128 p. Now I gotta chew on that for a minute. P, I can even use my calculator, so I will go to my calculator and get 105 squared, and then I will divide it by 128. Okay, 105 squared is 11,005. No, 11,025. And then I'll be dividing that by 128, and that'll be my distance to the focal point. So I don't have the decimal number. I didn't do the division in my calculator yet, so I'll just leave that fraction for now. It looks good enough for me. So let me put it back into my equation. X squared must be 4 times that fraction, 11,025, over the 128 y. And so 4 times 11, I can take 4 out of the 128 and reduce that. So x squared equals 11,025 over 30, back to 32, hello, y. So there's your perfectly good equation. It works for me, okay? That was all he wanted you to do. What did B say? The receiver must be placed at the focus. That's what I was telling you. How far is the vertex of the parabolic dish should the receiver be located? So I told you I couldn't tell how far it was supposed to be, not by the numbers they gave me, but we know that if P is the distance, 11,025 over 128, let me go back to the calculator and let's see roughly what it is. Okay, calculator says that that's approximately, again, I hit the wrong pen. It's a little bigger than 86. It's approximately 86. I'm going to put that down. I think it was 0.1 something. 86. So the ordered pair should be 0, because we're at the axis, approximately 86. Or you could say, or 86 feet above the vertex. Straight up, straight up. Okay, and that's good enough. Yeah, there's taking you the ellipses. So I'm going to work on ellipses and hyperbolas in one lesson. And bottom line is, all this stuff this week will be due Friday. You you can find the time to finish up your work through Friday. All right. Over and out.